My name is Shane O'Neill. Welcome to my presentation for PRESChain, my final year project. I'm just showing you my webcam here to show you that I am the one giving the presentation, so I'm just going to jump back onto my screen here now. So PRESChain is a smart solution to old problems, connecting prescriptions on a single decentralized system. The introduction, who am I? My name is Shane O'Neill, as I just said. My student number and email address is there. I'm in the software development stream for BSHC in the evening time, and I have come up with this solution called PRESChain. So what is PRESChain? Who, what, where, when, how? So PRESChain is a decentralized system that aims to connect all the entities involved in the prescription giving and receiving process. So I'm talking about like your centralized industries such as like the HSE, your GP or your doctor, the patients and the pharmacies, all connected on one system. So connecting our industries and people on one decentralized system. What are the benefits of this? Well, one is that it creates more transparency in the field. So there's a lot more transparency for people who are prescribing prescriptions and people who are receiving prescriptions. So they're able to have more visibility over what they're being prescribed, and it also creates a digital system for them to be able to use that in the process as well. And it uses tokenization. So instead of using a piece of paper with your prescription on it, it's now what's known as an NFT, a non-fungible token, on the Ethereum blockchain, which is minted to the user's Ethereum address. The system is mobile, so you can connect anywhere in the world as long as you have an Ethereum address, which I'll get into now in a few minutes. And how it uses blockchain, the new big buzzword going on in technology these days. So that's just kind of a bit of an overview on what it is as we get deeper into how it works in the demo. So the technologies, what technology did I use? So when developing a smart contract, your kind of back end, where your server and your database and all that is your blockchain and your network. So for my back end, I had to basically write the smart contract in Solidity, hosted on the Ethereum blockchain using an ERC721 standard for non-fungible tokens. So fungibility in terms of tokens comes down to whether or not it can be replaced by another token on the network. So let's say, for instance, cash is fungible, because if I give you €1 coin and you give me another euro coin back, it doesn't really matter which one you give me, because they're fungible, they can be replaced. An ERC721 standard means that these are non-fungible tokens, so they have unique IDs, unique representation for the data on the token. I used the Ropsten network for deploying this particular contract, because it's not fully something that can be implemented right now, because there's still a lot of things that need to be developed on the blockchain system ecosystem in general. So this is kind of just a concept. So I deployed it on a Ropsten network, which is a test net on the Ethereum blockchain that runs side by side. I also used Truffle. For this is kind of in the development phase. Truffle allows you to create a local blockchain on your local system. So the middleware. So I put in here, middleware is your browsers, your MetaMasks, Coinbase wallets. All of these intermediaries between the Web3 element, which is the blockchain, and the standard that people use generally on a day-to-day basis, which would be their web browser. So MetaMask is a plugin, which I'll go into now in a few minutes when I do the demo. It's a plugin to your browser to enable it to connect to Web3 systems such as Ethereum, EOS. MetaMask only works with Ethereum, but I won't get into that right now. and any other crypto wallets that you might use. I'll show you how my Coinbase wallet can interact with this particular contract as well during the demo. And the front end would be your regular HTML, CSS, JavaScript, using a bit of Node.js and Web3.js, and that's how the contract and the web interface interacts with the blockchains using Web3.js. So testing. This is just a kind of quick overview of my testing. I used the Mocha testing framework, and using truffle assertions inside of this framework, I was able to test each individual function that I've written for the contract. So I'll get more into that when I go into the questions at the end. So I'll do the demo now. So the demo starts with the prescription. So the contract has been deployed to the Robston network. You can see here that when I click on my MetaMask, I'm connected to the Robston network. I have my my account that I'm connected with. This is the account that deployed the contract. So you can see here that the owner of the contract is this current address. There may be some delays in transactions processing, but I will try and pump them full of gas so they go through quicker. So don't mind the names of these accounts just yet, because they don't actually matter. So at the moment, the owner of this contract is the account 1. So what I want to do is I want to deploy this contract. Sorry, the contract is already deployed. So what I want to do is I want to set the doctor on this contract. So what I'll do is I'll put in the address that I wish to set the doctor on. So I'll set the doctor, and then I can see that MetaMask is prompting me to put in to start a transaction. So I'll confirm that transaction, and it'll send off. So it may take a few seconds for the transaction to go through, but I'll also jump in here and see if I can speed it up. So I'll just pump it full of gas and save that transaction. So essentially what I'm doing here is I'm allowing the doctor that is involved, that owns this prescription, to be able to mint tokens to their patients. So I could be the HSE here, and I could put in an address of a GP, and I could set that doctor to be able to connect to this this website and start minting tokens to their patients. So I'll jump into the doctor's interface. So when the doctor connects, he will connect to this interface here, which you can see there's a few more fields than what the creator had. So I'm going to swap over to the account that is now the doctor on the contract. So you can see that the B9, and when I click on this, B9A is the correct address. So I'll just refresh that so it connects with this address. So now what I want to do here is I want to start prescribing drugs to my patients. So what I'll do is I'll start entering something in here. So I'll put in Lexapro. The drug code is called LX150480 or whatever it was. Dosage 20 milligrams. Okay, and I'll add that data. So that adds it to an array within the JavaScript here on the actual website. And now I want to add another drug here, so I'll call it Decavit, and it's just give it a random code and give it some dosage. So I'll add that, and if I leave anything here blank, I'll get an error, to say that you can't do that. And even if it got past here where I had an empty array going in the contract itself, there's some error handling to stop it from taking any empty inputs in here. So now that I've added 2 drugs to the prescription, what I want to do is I want to send that to another account. So what I'm going to do is I'll actually try and send it to my account on my phone, and then I'll show you how it can interact with other wallets and stuff like that. So if I go into my drafts here, this is my address for my phone. So this is my personal Ethereum wallet address that I can put in here. and I'm going to mint the token. I think I already have a couple of tokens minted, so I'll just call it number 5. So this is the ID that separates it from the other prescriptions that are sent on the chain. So now I'll just confirm that, and I'll send it off to my phone's address, and go back in here, and I'll just speed up the transaction for the sake of the presentation. And what I can do is here, if I have a drug that's already been prescribed, like this one here, if I put in the ID of that token and I hit get data, then I can see the information that's been put onto that drug. I kind of use these two drugs for a lot of testing, so that's kind of why I chose them again. So now I'll just jump over to my phone and see if I can get the prescription to show up on my phone. So what I'm doing, you can't see it right now, but I'm moving to the phone here and connecting to the Ropsten network. So I'm going to just put on my webcam here. So when I connect to PRESChain on my phone, I'm presented with this screen here. So I'm in what's called the Coinbase wallet here. So when I hit get prescriptions, it shows me the prescriptions that are assigned to my ID, or sorry, my wallet address. So if I click on number 5, let's say, and so what I did there, if I click on number 2 or number 5, it'll show me the data that's on that prescription. Okay, and what I can do then is I can send that information to the pharmacy that I wish to get the drugs from. So I'm not going to do that on my phone because I don't want to stand here like this. So I'll just jump back over to the screen here. So I had a bit of an issue with the Ropsten network trying to send on the web interface. So I'm just going to send the prescription here. You can see that I've put in the prescription ID and the transfer address. So that's going to be the pharmacy that I'm sending it to. So what I'll do is I will try and show you this. So I'm going to send the prescription, and then it's going to ask me to confirm the transaction, which I will do, and authenticate. So that's going to go through, and hopefully now in a second we'll have it back on the screen. So I'll just pause here while it goes through. I'd just like to show you here, I can see the transaction is going through on the Ropsten network. So this is a good way to verify that your transaction has gone through and check the status of it. So at the moment you can see that it's pending. So I'll just come back to this now in a second when it's displaying correctly on the screen when the token is transferred to the new address. So now that I can see that the transaction has gone through on my phone, it took a few seconds. So now what I've done is I'm connected to the pharmacy interface here with the address that I sent the contract to, or the token to. So if I hit get prescriptions now, I can see that ID 5 has now been transferred to the pharmacy. So if I click on that, I can see, whoa, okay, I have some drugs associated with that, and as the pharmacy, I'll give them the drugs and I'll hand them over. And what I do with this token then, now that it's no longer needed, is I'll burn it. And what that means is it removes it from the network. So if I just go back to here, you can see that there's a total supply of 3 tokens on the network. So that means that there's 3 active prescriptions out there at the moment that haven't been claimed. So when I go back to the pharmacy's address, only this address, and subsequently all the other functions that I've run, only the addresses that are allowed to run those functions will be allowed, and that will kind of be a bit more clearer when I go through the code. But right now I just want to burn this token, so I put in number 5 and I burn the token, and then I get another transaction in MetaMask and I hit confirm on that. Okay, so as we just wait for that transaction to go through again. I'll just try and pump it again with some gas, and essentially what will happen, it will remove the prescription from the network. So if I click on the transaction is confirmed, I will click on get prescriptions again, connected as a pharmacy, and there is no ID associated with this address anymore because I've burnt it. And if I go back to the creator, I can see there's only 2 tokens left associated with this contract. So that means that the token is now burnt. And in the background, what it's done is it's emitted an event that had all of the data that was on the prescription, so all of the drugs that were prescribed, and people can scan the blockchain and listen for those events and start to build up some data sets for use in research or governmental purposes and stuff like that. So that's kind of how it works. It's a bit more difficult to explain remotely. If I had, if I was able to interact with you guys a bit more, it might be able to answer some questions that you have, because it's a relatively new technology, and how the blockchain functions and the digital IDs and the digital signatures is a bit of a new concept to a lot of people anyway. So what I'll do now is I'll just quickly go through the code because I'm conscious of the time. So I'll explain the mappings first. So, not the mappings. I'm going to show some modifiers. So these modifiers are used in kind of handling who can use certain functions. So like the only owner modifier requires that the message.sender = owner. Okay, so we set that in the constructor. We set that the message.sender, which is the deployer of the contract, is set to the owner in this global variable. Okay, so that means that whoever deploys the contract to the blockchain owns the contract. And then doctor, we set doctor through the set doctor function, which is up here, which can only be so by pinning the modifier to the end of the function call, we can say that only this particular address, the message.sender, can use this function. Okay, so we've now set the doctor on that. So now we go back into the PRESChain. So this is the contract that I've written for the token and the smart contract. So there's a couple of mappings here which map the owner to the ID of the prescription, and an array of the prescription IDs that belong to a specific owner, a struct for the data, then the main function calls that we use are the batch that sets all of the prescription data onto a specific ID, which is down the bottom here, which is in here, add prescription data batch. Okay, so what this does is it separates it gets all the information that was put into the JavaScript. It makes sure they're all the same length and they're not empty. Not empty is done down here. Make sure that they cannot be null. So these kind of trigger different functions within the contract to reduce on transaction costs and the amount of transactions that are occurred. So if you think about it, if I didn't do this batch array, I'd have to do an individual transaction for a mint function. I'd have to do an individual transaction for each piece of data that I want to put into the prescription, and then another transaction for adding that data to the prescription ID. So if you have any feedback or have any more questions on this, I'd love to take some. But I'm just trying to quickly go through how the process works. The mint function is here. So these require statements. I've gone through them in the documentation. They're basically they require that these two instances are true. They're basically if statements only. If they're not true, the function will fail and the transaction will not succeed. So you have to make sure that these things are correct before we go on to the next part of the function and perform a transaction. So this little comment here, if there's any error, it'll probably trigger the require statement and give you back the error that's shown. There's a couple of things with the mappings where mappings are essentially like parts of memory where these particular IDs are, and where they're mapped to other sections of memory on the blockchain. I probably wouldn't go too deep into that now because it can take a while to explain. But then if I go into the JavaScript here, this is where all of the functionality between the interface and the contract is stored. So you can see that I have a transfer function, burn token function, and what it does is it calls the contract instance that I've started here. So this is the contract address that's on the Ropsten network at the moment. So then I take in the ABI, which the ABI has basically all of the parameters of all of the functions, and it puts them into one file. The contract address, which is this address of the thing, and so whoever's sending or deploying the contract is going to be account 0. So I can go into that in more detail if there's any questions. Then what we do is we grab the contract instance, we take the methods that are associated with that contract instance, and then we grab the method that we want to choose from those and send in the parameters. So you can see that there's all of these different methods that are inside of the contract, and they're all in the PRESChain.sol file. So just to touch on a bit of testing, my testing framework, the framework that I used was the Mocha testing framework, which is a JavaScript based testing framework, and truffle assertions, which is a module that you can use for testing smart contract methods using these truffle assertion buzzwords or keywords. So let's say for each method that I wrote, I have, let's say here, this set doctor function. So there's a couple of ways that this function can be used nefariously, which would be, like the doctor being able to be set to the contract owner, and then they could start prescribing drugs to themselves. That's for instance one of the things that we want to negate against. So I write a couple of different tests that make sure that they could fail or pass depending on, so can only be called by the owner. I want this to pass this particular function call, so I let the instance equal the instance of the contract that's on the network, and the owner equals the owner of the contract. So without getting kind of too bogged down into the details, basically you assert that this particular function call will either pass or fail based on the inputs. And if I just jump back into my presentation, you can see that all of these have passed in some capacity. So that means that everything that I think should have happened to the contract has happened. So hopefully that's a bit a bit of an explanation onto the unit testing that I've done for my project. So now I'll just quickly answer these questions. So discuss the most difficult aspect of my project. So the most difficult aspect that I found was finding resources to figure out how the underlying blockchain works, how the code interacts with the blockchains, and then especially figuring out how NFTs work, the non-fungible token aspect of this decentralized ecosystem. So that was definitely the most difficult part, but it was also the most enjoyable part to find out and learn a whole lot more about stuff that I didn't understand before. Discuss the most innovative aspect. Well, I think the innovation comes from the fact that it's a new technology, it's something that hasn't been done before, it's addressing a specific problem that people may not think about. I know that St. James's Hospital is definitely looking at some sort of digitizing prescriptions, and One thing that I just wanted to note actually would be that to stop people from being able to spend prescriptions more than once, there is a function or a check, or what is it called, a mapping that checks is this token transferable. So when the token is created, the is transferable function is set to true, and then once it's transferred, so as you can see in this transfer pres, it sets it to false. And once it's set to false, it means that it can never be transacted with again, because in the system of prescription handling, and even like the physical way, is that you should only really have to get the prescription from your doctor and then send it to your pharmacy. And if you send it any other way, that could be used nefariously. We don't want that to happen. So we don't want you to be able to send it to your mom and her go to the pharmacy and get the drugs in her name. So that stops this kind of madness going on. So with respect to your requirement specification, I haven't really added any more requirements to the project. It was more kind of understanding how the contract itself would work. So I think in my first technical document, I was talking about the contract being the prescription as opposed to the non-fungible token being the prescription. So that was something that that kind of changed, but in reality the requirements didn't actually change that a great deal during the development. My approach to testing, I think I kind of covered that a bit there already, using the testing, the Mocha framework and truffle assertions. So that's kind of I really individually tested every method that I wrote and every way that it could be manipulated to my knowledge. So obviously, there could be things that I've missed, but I definitely tried to cover all the bases. If you were to start the project again, would you change any decisions? Definitely, I would. I think it's one thing that when you finish the project is all the stuff that you didn't know when you started. So I would absolutely go back and I could start the project again, maybe understand a bit more about the blockchain side of it, NFT side of it, how the contract would interact with the web framework that I was using, all sorts of things. I would definitely change. Am I happy with the project? I'm absolutely delighted with the project and how it worked out, and I think it was a cool idea, and I definitely think that it could be used, and that's kind of it. I think we always you can always look back and say I would have done this thing differently, and if I was to start it again or start a new project with a similar technology, I would have a whole lot more knowledge on how it's going to work. So thanks very much for sitting through that. Hopefully that was enough. If you have any questions, please don't be afraid to reach out. And yeah, thanks very much.